Okay, so today we're going to finish up right triangle trig. Okay, section 4.1. Same section as yesterday, just part 2. Okay, all the problems we do today are going to have the directions in it: solve the following triangle, or solve the triangle. Anybody have an idea what that means? When you solve a triangle, what do you think you have to find? Yep, John? You got to find angles. Yep, we're going to find all 3 angles. What else? Nathan?
Trig functions.
We might use a trig function to find what I'm thinking of. What could we use? What do you think we're going to use the trig functions to find? John? The sides. Yep. So to solve a triangle means find out how long each side is and find out how big each angle is. Right? So there's 6 things you have to find. 3 sides, 3 angles. Any problem that they give you, they got to give you 3 pieces of information. So they're going to give you half of what you need to find. Okay? If they don't do that, you won't have enough information to solve the problem. So one thing they could do is give you a side and one of the angles. And really, the third piece of information here that you have, it's a right triangle. Every problem is a right triangle. So what do you automatically know you're going to have in every problem?
90 degrees.
A 90-degree angle. That piece of information is common to every problem. So in addition to having a 90-degree angle, I've got to either give you a side and another angle, or in addition to the 90, 2 of the sides. Okay, but these are the only 2 cases I can give you. It wouldn't help if I gave you 2 of the angles, because if I give you 1, you already know the other one, because they all add up to how much? They all add up to 180. So these are the 2 cases we're going to do. We'll start with the top one, and then we'll try maybe a couple of the bottom one. All right. Usually this kind of problem lends itself to making a sketch. Right? Because what you're going to do, you're going to look at what's opposite, what's adjacent, and what's hypotenuse. If you're okay visualizing things in your head, you just can visualize what's across from what. You don't need a diagram. Don't make a diagram. Okay, but for most people, I think the diagram will be helpful, so I'm going to do it. And then once we have a diagram, we'll organize our information in a table. Okay, the table is just to kind of keep the numbers organized so we don't have stuff all over the place. All right, so here's the information they're giving us. 1 of the sides and 1 of the angles. Okay, so first thing you want to do, make a sketch. Okay, you got to label what's going to go where. So let's make a triangle. Okay, it can be any kind of triangle you want. It can face any way you want. I did mine that way. Make sure it's got a right angle in it. Hey, Andy, what are the 3 things we use to represent the sides?
A, B, and C.
Yep. We use A, B, and C. Okay. It doesn't really matter where you put A and B, but C you should put as the hypotenuse. Okay, and how about my angles? Anybody remember the 2 letters we used for angles? Yep.
Alpha and beta.
Yeah, alpha and beta. And alpha and beta have to go in certain spots. Where does alpha go?
Across from A.
Yeah, good job. Alpha always goes across from A. And beta always goes across from B. So there's our diagram we're going to plug into. Anything that I know, I can erase and fill in the actual value. But that's the basic diagram you're going to use for every problem. Any questions on that diagram? All right, now let's fill in what we know. Okay, B is 2, and then alpha is 40. Okay, also, we're going to do all of these problems in degrees. We're not going to use radians. There's no reason you could do this all in radians, but we're just going to stick with degrees. Okay, so here's our table. What I did in the first column is I put the 3 sides. In the second column, I put the 3 angles. And I put A across from alpha, B across from beta, and C, that's across from the right angle, which we already know is 90. Okay, the other thing I did is I put a box around everything we need to find. All right, so 3 things we need to find: A, C, and beta. All right, is there anything I can find here that would be pretty quick? In fact, you don't even need trigonometry to do it. Just need to know a little bit about angles in a triangle from geometry. Alex?
Beta is 50 degrees.
Yeah, how do you know beta is 50? You're correct.
Because 90 plus 40 is 130. Subtracted from 180 to get 50.
Yep. Okay, you already used up 90. You used up 40. How much is left? 50. All the angles have to add up to 180. Okay, so beta, we're good. We're done with that. Now, my advice when you're solving a right triangle problem, don't ever use something you found to try and find something else. Why do you think it's a bad idea to use this 50 to say try to find A or C? I could, but it's a little dangerous to do it that way. How come?
Because you don't know if it's completely correct.
Right. If we made a mistake finding beta and you use it to find A, well, what's going to happen to A? A is wrong. Right? If you use beta to find C and you made a mistake on beta, you get C wrong. Right? We're going to find A using only what was given to me. I'm going to find C using only what was given to me. All right? Because what was given to me, I know is correct. All right, so we found beta, we're done with it, we're never going to use it again. All right, next thing, let's find A. It's on my diagram, I'm going to circle what I want to find. And I'm going to circle the 2 things that were given to me. 2 and 40. All right, now at this point, I've got to use a trig function. My 3 choices are sine, cosine, or tangent. You're never going to use secant, cosecant, or cotangent. It's not that you can't, it's just you don't have a button for them. So if we use one we have a button for, this is easier. So my choices are sine, cosine, and tangent. To figure out which one you're going to use, look at the angle I circled and figure out the names of these 2 sides. Are they opposite, adjacent, or hypotenuse? Callie, what's the name of side A relative to this angle?
Opposite.
Opposite. Okay, so we need a trig function that has opposite. Nathan, what's the name of the bottom side relative to the 40?
Is it opposite?
A is opposite. Okay, because that one's across. That's adjacent. Right? So we know the side adjacent. We want to know opposite. What's the only trig function out of sine, cosine, and tangent that has opposite and adjacent in it? Tangent. Yep. So what you do is you write tangent of your angle, tangent of 40, equals opposite, is just like what we did yesterday, over adjacent. And let me just move that. Now my last step, I want to get A by itself. So how do I get rid of dividing by 2? Multiply by, yeah, just 2. Yeah. multiply by 2. So the 2's are gone. And I get A equals 2 tangent 40. And that's it. We're going to plug that in, but that part's easy. Right, so now just figure out what that comes out to. Okay, make sure you're in degrees. Okay, all the problems today are in degrees. I'm going to type in 2 tangent 40. Okay, so A is about, let's just round, let's go to 3 decimal places, 678, 1.678. So now we only have one thing left to find. Okay, now that I know A and I know B, what could I do to find C?
How we do it?
Pythagorean theorem.
All right, I could do Pythagorean theorem. But why do you think that I think that's not a good idea?
It's going to be really difficult to do because of the decimal.
Well, we can use a calculator. You don't have to do anything in your head here. So we can use a calculator. But what's another reason why I wouldn't want to use Pythagorean theorem to find C? All right, first of all, we got a decimal. This is not an exact answer. Okay. Where did I do it? Right here. That's not even an exact answer. Okay? That's rounded off. If you use something that's rounded off to find something else, that's going to be rounded off even worse. Why else is it a bad idea to use A, besides the fact it's rounded?
Because we found it.
We found it. This might be completely wrong. So if this is completely wrong and you use it, guess what? Anything else you find is going to also be completely wrong. Right? So if we want to find C, we're going to go back to the 2 pieces of information that we're given. We were given this, and we were given that. Okay, so now we're focusing on everything that's circled in green. We want to find C. We were given the 2, and we were given the 40. Okay, forget about A. A's done, we're not using A. What are the names of the 2 sides circled in green? Start with the 2. Yep, okay.
Is it like, are we saying like adjacent?
Yep.
Okay, adjacent.
Yeah, that's adjacent. All right, so we got to use a trig function that has adjacent. And what's the name of side C? Hypotenuse. Okay, what's the trig function that has adjacent and hypotenuse in it?
Cosine.
Cosine. Okay, so we're going to set it up the same way. Cosine of 40 equals adjacent over hypotenuse. Adjacent is 2. Hypotenuse is C. Okay, and our goal is to do the same thing. We want to get C by itself. So here's our original problem. First thing I want to do is get rid of this fraction. So what could you multiply each side by to get rid of this denominator? Think about if you had something like, what would you multiply each side by here just to get rid of that number? What's the opposite of divide by 3?
Multiply.
Multiply by
3.
3. It cancels those out. Okay, so what's the opposite of divide by C?
Multiply by C.
Multiply by C. Yeah. So multiply by C. Multiply by C. Okay, what that does is it cancels those C's out. And we get C times the cosine of 40 equals 2. And now my last step, I want to get C by itself. So how would I move cosine 40 to the other side? I would what? Yeah, I would divide. This is just C times a number. Okay, I don't know what the number is. I could find it if I wanted to. 0.77. C times 0.77 equals 2. You're going to divide by cosine 40. Don't round it to 0.77. just divide by cosine 40. And divide by cosine 40. Okay, so my final answer is 2 divided by cosine 40. And we'll type that in and get our decimal. Okay. Notice the original problem and the final answer. Look at what happened with the c and the cosine 40. What happened there? Yeah, they just swapped places. Okay, so anytime you've got a number on the left, a number in the top, and a letter in the bottom, you can just swap those two things. If you want to see why, just go through what we did. But these just swap places. C equals 2 over cosine 40.
Couldn't you have, in that problem, divided it or multiplied it by 1/2 instead of times equals C?
So in the original problem, multiply by 1/2. So if you do that, multiply by 1/2 and 1/2. Okay, the 2's would cancel out, and you'd be left with a 1 in the top and a C in the bottom. So what would happen here is you would get C by itself, but it would be in the bottom of a fraction, not the top. Does that make sense? All right. Then we'd have to fix this. So I think the easiest way to do it is that way. All right. Anybody get the decimal for that? What 2 divided by cosine 40 comes out to? 2.611. Okay. And that's it. That's how you solve a triangle. Now, what we could do, okay, is to check it, if you've got extra time, see if 1.678 squared plus 2 squared equals 2.611 squared. This is kind of like a way you can check it. Try the Pythagorean theorem and see if it works. Okay, let's take 1.678 squared plus 2 squared is 4. We get 6.816. And now take 2.611 and square it. 6.817. So does that mean we did something wrong because they didn't come out the same?
No.
Why did they come out different? Because we rounded. Okay. Even rounding to 3 decimal places, it's not going to make it come out the same. Right? 6.816, 6.817, they came out the same. All right? Which makes me feel pretty confident we did it right. Right? So that's how you can check your answer. Okay. Any question on that one? All right, so let's try one more of those, same type. Okay, they're starting you off with a side and one of the angles. Okay, before we do any work to find answers, what do you think I should do first? Yeah, I should draw a picture. Okay, unless you're really good at your head at visualizing beta and figuring out what's opposite beta and what's adjacent to beta. If you can't do that in your head, you need a picture. Right? It doesn't matter where you put A and B. Just make sure wherever you decide to put A, put alpha across. Okay? Wherever you put B, put beta across from it. Right? So I'll do A as the height. Okay, and you know what? I'm going to fill it in since I know what it is. A is 6. Alpha is across from it. B I don't know. Beta I do know. Put that across from it. There's your diagram. Okay, if yours looks a little different, just make sure 6 is across from alpha, 20 is across from B. That's all that has to happen. Right, and Brandon, what can I get here pretty quick without too much work?
Alpha,
Yeah, we can get alpha pretty quick. What does alpha come out to? 70. Okay, check and make sure those all add up to 180, and they do. Okay, Lauren, are we going to use alpha to find B or C? Why not? I mean, we could, but why is that a bad idea? Yep, because we found it ourselves. So if that was wrong and we use it, everything else is wrong. So we're going to go back to what was given. All right, you can find B or C first. It doesn't matter. So Derek, which one do you want to do first?
Let's do B.
B? I'll just go right in order. All right. So I'm going to circle the one I want to find. And I'm going to circle the two things they gave me, 6 and 20. Okay, focus on those three things. Okay. From this angle, I got to figure out the names of the two sides I'm working with. One of the sides I know, one of the sides I want to know. Okay, so look at that for a sec, see if you can figure out these two names. And again, by names, I mean opposite, adjacent, and hypotenuse. Yep.
It's adjacent, I thought, opposite.
Adjacent and which one?
Opposite.
Opposite. Yep. Adjacent and opposite. Okay, and Jacob, what's my trig function that has opposite and adjacent in it? Tangent. Yep. So let's set it up. Okay. Tangent of 20 degrees. Always plug in your angle right next to the tangent. Tangent of 20 equals, Dakota, what's going to go on the other side?
B over 6.
Perfect. B over 6. Okay. And Kaylin, what's my last step to get B by itself?
Multiply by 6.
That's it. There's B. 6 times the tangent of 20. Okay. Again, type it in, round it off. 6 tangent 20.
How we do it here?
If you've got a different calculator, you might have to do it in 2 steps. You might have to find the tangent of 20 first. Okay? And then after I get that answer, I can hit times 6. Okay, that work? Yeah. Right, so we got 2.184. All right, now I got 2 out of 3 sides. Allison, should I use Pythagorean theorem? I got enough information to do it. No, why not?
Because then it won't be right.
Right, if B is wrong, you're going to get C wrong. So don't use Pythagorean theorem. If you want to check your answer, fine, do it that way. But to find C, circle what we want to know. Go back and circle the 2 things you were given. 6 and 20. So focus on the 3 things in green. Okay, Ashley, what's the name of side 6? Adjacent. And side C? Hypotenuse. Okay. What trig function has those 2 in it? Yep.
Cosine.
That's cosine. Okay, so it's cosine of my angle equals adjacent over hypotenuse, 6 over C. Now this is the case where you've got the number, you got a number on the top, and you got a letter in the bottom. What's the trick to get C by itself quick? You could multiply by C and go through all the work, but what's going to happen?
Just swap C and cosine 20.
Yeah, just swap these 2 things. All right, if you multiply by C and then divide by cosine 20, all that's going to happen is they're going to swap places. Look at the last example we just did. So what's C?
6 divided by cosine 20.
That's it. Okay. Does that swap it? Does that confuse anybody? Just swapping them?
I got a 0.93.
You got 0.93?
How much did you get that?
6 divided by cosine 20. Okay, anybody else get 6.385?
I did.
You did? Ashley did? Yep. Okay. Okay, if on your calculator you're not sure how to type it in, I'll let you use one of mine the day of the test. Because mine, you type it in just like that. Press 6, divide, cosine 20. Exactly the way I just did it. Okay, any question on that? Okay, I'm not going to check it with the Pythagorean theorem this time, but you could. All right, so that's the case where they give you two sides. I'm sorry, one side, one angle. What's up, Charlie? All right, so that's the case. They give you one side, one angle. Okay, this one's a little different. This time they're giving me two sides. Right, so what can't I find here right away that I was able to do in the last two problems? The angle. Okay, in the last two problems I had the 90. I had another angle, so I could find the third angle very quickly, knowing they had to add up to 180. I cannot do that here. But there's now something else I can find right away.
The third side.
I can find the third side. How can I do that?
Now when you use the Pythagorean theorem.
Yeah. How come I'm saying it's okay to use the Pythagorean theorem now but not before?
Because two are given.
Yeah, these are both given. You're not using anything that wasn't given. Okay, so we use Pythagorean theorem and find C. Right, so we got a squared plus b squared equals c squared. 3 squared is 9. 2 squared gives me 4. C squared is 13. So what's C? Square root of 13. And let's just round it off. Yeah, for this, whenever you're finding the length of a side in a triangle, you can round it off. Okay? You can use a decimal, yeah. So for tonight's homework, you can use decimal. When you're finding trig functions, you're just finding the sine, the cosine, tangent, secant, cosecant, cotangent. Do not round anything off. All right. So the length of the side is 3.606. 3.606. Just like we've done before, forget about using C to find anything else. We've talked about why. All right, now what I would do is set up a diagram. You don't really need a diagram. Most people can do Pythagorean theorem without it. But once we start to get into opposite and adjacent, it's probably a good idea to have it. So we'll put A, alpha, B, beta. Okay, I'm going to label that as C, even though I know it's 3.606. I don't want to accidentally use it. So we're going to find alpha and beta. Zach, which one do you want to do first? It doesn't matter.
Let's go with alpha.
Alpha. Okay, so I'm going to circle what we want to find. And what are the two pieces of information we were given?
A and B.
A and B.
Great.
So we go through the same thought process. Find the names of these two sides.
Opposite and adjacent.
Opposite and adjacent. Okay, what trig function is that?
Tangent.
That's tangent. Okay, so this time it's tangent of, what's my angle?
We go with alpha.
Alpha, yep. And what goes on the other side? 3 over 2. Okay, what's a little different about this one?
We're taking a tangent of an unknown angle.
Yeah, we don't know the angle. The variable this time, it's not in the top or the bottom of the fraction. It's in the argument. It's in the thing you're plugging into tangent. So,
Hold on. I thought adjacent was innovative.
so from this angle, opposite is across. Adjacent is the one that's right next to it. If we do something with beta in a minute, which we will, opposite and adjacent switch places. Remember, opposite and adjacent, they're like left and right. Depending on which way you face, they're different. All right, so now my goal here, I gotta get alpha by itself. How can I get rid of tangent? All right, so a lot of times people say divide by tangent, but tangent is a word. It's a function. So that'd be kind of like if I said divide by square root. Can't divide by a function. But you can do something that cancels out a function.
Inverse.
Inverse. Yep. So what we're going to do is take inverse tangent of what's on the left, and that's going to get rid of tangent. But if we do it on the left, where else do I have to do it? Got to do it on the right. So alpha is the inverse tangent. Okay, now you can see where we use inverse trig. Inverse trig is used anytime you don't know the angle. That's what it does. Inverse trig finds an angle. Regular trig, we use that when we're finding sides. Now just type that in. Okay, second inverse tangent, 3/2. Okay, 56 point, we'll round it up. 310. Okay, it rounds up. Now, if I was running out of time and the bell was going to ring in a minute and I didn't have enough time to finish properly, what could I do very quickly to find beta? Subtract this from what? Yeah, you could subtract, do 90 minus 56.31. And that's what beta should be. But if alpha's wrong and you use it to find beta, you just got beta wrong. All right, so let's find beta the same way we just did alpha. To find beta, use the two sides that were given. So focus on what's circled in blue. Okay, what are the names of the two sides I have now? Okay, it's still opposite and adjacent. Okay. It's still opposite and adjacent. So, tangent of beta. But what's the difference? Adjacent and opposite just switch places. Now the opposite is 2. Adjacent is 3. Okay. Any question on that? So it's tangent of beta equals 2/3. Okay. What am I going to do on each side to get beta by itself?
Inverse tangent.
Yeah, don't say times. I'm just going to take. Like take the square root, or we're going to take the inverse tangent on the left and take the inverse tangent of what's on the right. Okay, so beta is the inverse tangent of 2/3. And hopefully, if it comes out to 90 minus 56.31, then we definitely did it correct. So let's take second inverse tangent of 2/3. We get 33.69. Let's double check it. Let's take 90 minus 56.309. Yep, they come out the same. Right, so 33.69, round it to 0. Okay, any questions on that type? Anytime you're missing both the angles, you're going to have to use inverse trig. Right? If you're missing both the angles, you have to use inverse trig. If I give you one of the angles, You're not going to have to use inverse trig. Just use regular trig. Right, so last one, try that one on your own. Okay, see if you can set it up. Just by quickly looking at it, are you going to use inverse trig or not use it? You're going to use it. You're missing 2 angles. Okay, so you're going to use inverse trig. Okay, if you get stuck, just let me know and I'll come help you out. Yep, if you need a calculator, I will put them at the front table. Why do we have to use inverse trig? Because what's happening here? Yeah, we got to find both the angles. Okay, so first thing I'm going to do, let's use Pythagorean theorem. We'll find A. Right, so A squared, B squared equals C squared. All right, so you get A squared plus 9 equals 36. Okay, bring the 9 to the other side. You're going to get A squared is 27. And A is the square root of 27. Okay, what does that come out to? Okay, 3 root 3, you can round it to a decimal, that's fine. 5.196? Okay. Now, one thing I didn't mention that you can also kind of use to help check your answer, the biggest side is always across from the biggest angle. Okay, the smallest side, that's going to be with the smallest angle. And then the middle side should be with the middle angle. If that doesn't happen, something's wrong. Okay, so you can always just look at that real quick and make sure that works as a check. Right, make your diagram. Okay, this time we'll put A there. We don't know it. Well, we weren't given it. Put alpha across. B, beta, and C. All right, so let's start with alpha. Okay, to find alpha, you're missing opposite. Okay, so I saw some people tried to use tangent, but you can't because you don't know opposite. You know adjacent, but not opposite. Okay, so what are the names of the 2 sides that I do know? Adjacent and hypotenuse. Okay, what trig function has adjacent and hypotenuse? Cosine. Okay, we already got a letter on the left. Everything else on this right side better be a number, or we're not going to be able to solve it. Okay, 3 over 6. Question was asked, should I reduce this? It's up to you. You're going to use the calculator in a second anyway, so it doesn't really matter. My last step, how do you get alpha by itself? Yep.
It's negative cos. I
Yep.
don't know the word for it.
Anyone help him out? What's the name of that? Inverse. Take the inverse cosine on the left. Those are gone. Do it on the right. And what do you get for alpha? 60. Anybody else get 60? Yeah. That's 60. So if we do beta correctly, it should come out to what? Should be 30. We're going to find beta. Okay, use the 3. Use the 6. And which 2 sides do I know this time? Opposite and hypotenuse. Okay, which trig function has opposite and hypotenuse? Sine. All right, so now we get sine beta equals 3 over 6. Take the inverse sine of each side. Oops. Inverse sine of 3/6. Okay, and if you type that in, what do you get?
I got
30, yeah. You will. Inverse sine of 3/6. 30. Okay, which is exactly what we thought we should get. Okay, so any questions on solving right triangles? These will be the last 4 problems on the test. Probably 2 of the first type and then 2 of these type. good?
All right.
This one, you know what? Let's draw the diagram, but I'm gonna let you solve it for homework. Okay. But I'll help you draw the diagram. It says you're going to take a 20-foot ladder, lean it against the house. The angle between the ladder and the house is 17 degrees. How high will the ladder reach? Okay, so here's our ground.
Are we going to have a lot of these type on the test, like the word problem?
Yeah, there will be one word problem. Yeah. Okay, here's our house. We're going to lean a ladder against it, just like that. And we can assume that the house is built correctly. It's perpendicular to the ground. And it says the angle between the ladder and the house is 17 degrees. Okay, the ladder is the black line. The house, that's the green line. And it says the ladder is 20 feet long. Okay, so what is the ladder really in this problem?
The hypotenuse.
Yeah, it's a hypotenuse. You draw this triangle off to the side. There's your ladder. There's the angle with the ground and the house. There's the angle between the ladder and the house. And they want to know how high the ladder will reach. So what do I have to find in that triangle?
A and B.
Which one?
Wait, the one on the height.
Yeah, I just have to find the height, whatever you want to call it, A, B. Find the height of that triangle, and you're done. So you want to find that. Use those two things to do it. So there's your diagram for the word problem. Okay, finish that one up for homework, and try those problems on 255. Okay, so it's 31 to 39. Again, just odd. Some people did all last night, just the odds. 43 to 47, and then 51 through 55 odd. Okay, and try to finish the word problem. Okay, so we'll take a look at that first thing tomorrow. Then tomorrow will be a review day, and we'll have our test on Friday.